All right, continuing with part B here. The second part is coming up with your expected counts. You also hear that referred to as expected values or expected numbers. The way that you get that is you just take your sample size, which is 120 in this case. So you take your sample size and multiply it by what you think your expected proportion is going to be. And that's the proportions that you get from your null hypothesis. Okay, so that's, in this case, what the proportions were before the price change. So it's saying if there wasn't a difference in the number of sales in the different categories after the price change, then it'd be the same as it was before. So we use those percentages. So we go down, and you can see right here, we just take the sample size, which is 120, all these, and then multiply it by the proportion that was given to us. And this one right here should have been 0.15. Just making that little change right there. So 120 times 0.1 is 12. 120 times 0.15 is 18. Then we got 72 and then 18. So you're just multiplying that sample size times what you think the expected proportion is, and that gives you your expected count, or expected value. So essentially, if there wasn't a change in the distribution of box sales, we'd expect that in our sample of 120, then we would get numbers that come out to this. Now, if you look at our observed values, you can see obviously it's different, but it's kind of hard to see how different it is just based off looking at those numbers. So our chi-square test is going to help us determine how different it is and if it's a significant difference where we're going to reject or fail to reject the null hypothesis. So let's move down to part C. So we have our three conditions that we need to check. The first one is your random condition. So we know it's random because it's from a simple random sample. Second, we have our 10% condition. We can assume that they've sold more than 1,200 boxes, which is, as long as they sold more than 1,200 boxes, then our sample size of 120 would be less than 10%. We've done that all semester. You should be familiar with that. Then part 3, this is the one that's new. All of our expected values need to be greater than 5. And we can see all of our expected counts or values are greater than 5. So all 3 of these check out for our conditions. On to part 4, the significance test, calculating our p-value. So this is where we're going to have to use our formula that we learned up here. So this symbol right here means we're going to take the sum of all these different calculations and add them. So we calculate them and then add them all up together. So you take your reserve value minus expected value, square it, divide by your expected value. Not that complicated of a formula. It's just going to take a little bit of time. So for our small size, right here, we have an observed value of 8, expected value of 12. So I'll bring the expected value back on the screen there so you can look at it up top. So you do that and it comes out to 1.333. I recommend doing each of these calculations individually rather than trying to put all 4 in your calculator. It's going to be really hard to put in the calculator all straight through. So I just do the calculations and then write them down and you can add them up at the end. So then for our medium, we had an observed value of 24, expected values of 18. We subtract those, square, divide by 18, we get 2. And then we do the same thing for the large and jumbo. So we got our observed values, our expected values, subtract them, square, divide by the expected value again. Add up all those together, because remember it's summation, which means we add up all of those together, and that gives us 9.5139, which we can call our chi-squared value. And the way that we abbreviate chi-squared is x squared. I am not sure exactly why they decided to use the x for it, but that's kind of notation. So you need to know that goes with the chi-squared. Something else that we're going to need to know is degrees of freedom. So the rules for degrees of freedom is you take your number of categories minus 1. So we had 4 categories, small, medium, large, and jumbo, minus 1. That gives us 3. So our degrees of freedom are going to be 3. Now in the M&A activity, they used the table, which you've probably seen in your book and some of the other videos you've learned so far. Here's how we do it in the calculator. So you're going to go to chi-squared CDF, which is under second vars. Because second var is just where normal CDF is, TCDF. Basically the same thing, except we're going to go chi-squared CDF. Put your chi-squared value in. Want to label that. Your upper boundary is going to be positive 1,000. And then the last number is going to be your degrees of freedom, which is not 13, 3. Degrees of freedom goes after that, which is 3. On your calculators, that screen should come up where it kind of walks you through each of those steps. So it shouldn't be an issue at all. And when we get that, gives us our p-value of 0.0232. All right, so going down to our analysts, I'm going to skip part E for a second, go down to part F. So we can say since our p-value of 0.0232 is below our significance level of 0.05, then we have statistically significant evidence to reject the null hypothesis. So what that means in context is we have evidence that the new price changes the number, I forgot to finish this one, the number of boxes sold in each of those categories. Okay? Because if that probability, that p-value again is telling us if the proportions did not change, there's only a 2% chance that we're going to get the values that we got in our observation, which is very unlikely. So that means that they probably did change. So that is how you're going to interpret that. So we're going to reject the null hypothesis. Now going back up to part E, it's asking us what type of error we're going to use. Now if we reject the null hypothesis, the only error that we could have is a type 1 error. Because a type 1 error is where you reject the null hypothesis, but it is actually true. So if you reject the null hypothesis, the only type of error you can have is a type 1 error. So that's what we should have had. That's what you have for part E listed there. As you're finishing writing that down, the type 1 and type 2 errors, we're going to spend a good amount of time reviewing that in the next couple of weeks as part of our AP review. But good opportunity just to make sure you have that locked in. Got those two different types of errors memorized. The type 2 error would be where you did not reject a null hypothesis. You failed to reject it, but it was actually not true. Okay, so that's the second type of error that you could have, a type 2 error. So yeah, that's how we go through and do this chi-squared goodness of fit test. It's a lot of work, just like any other significance test, but just try to break it down and see how it relates to all the other significance tests that we've done so far. And it's going to make it a lot easier for you to go through and understand and memorize all the different steps.